You typed one sentence. The AI wrote 300 lines of code. And somehow, it worked. So why do you feel like a passenger in a car with no steering wheel? Here's the uncomfortable truth. The AI isn't the problem. The map is. React. Next.js, TypeScript. Bundlers. Package managers. The moment you start building, these words roll in like fog. And most people try to survive that fog by memorizing it. Bad idea. Because if you don't know the terrain on the other side of the fog, you won't notice when the AI cheerfully walks you straight off a cliff. So today we're not going to memorize anything. We're going to do something smarter. We're going to learn how this whole world got built one ridge at a time. And by the end, the fog is just gone. Welcome to Region 1, the front end. The land your users actually walk on, the part they see, tap, and complain about. And the oldest rock in that land is where every developer trips on day one. So let's start exactly there. With a mix-up that almost everybody gets wrong. Quick question. The internet and the web, same thing, right? Nope. And this is where almost everyone faceplants. Picture a national highway network. Asphalt, bridges, tunnels. It's just a way for things to travel. The road doesn't care what drives on it: delivery trucks, buses, ambulances. That highway? That's the internet. The physical cables wiring the world's computers together. So what's the web? The web is one specific delivery service driving on that road. Its whole job is ask for a document by its address, and whoever owns it sends it back. That's it. That's the web. And here's the kicker: the web isn't the only thing on that road. Your email? Different vehicle. Your game's live chat? Different vehicle. They all drive on the internet, right next to the web. So next time your Wi-Fi is connected but nothing loads, now you know. The little alley to your house is fine. It's the main road that's blocked. So who paved all this? Here's a fact that should honestly annoy you. This gigantic continent we live on every day? It started as one guy being mildly irritated at his office. 1989, CERN, the giant physics lab in the Swiss mountains. A British scientist named Tim Berners-Lee has a boring little problem: the lab is drowning in documents, and nobody can find who put what where. The files sit around like scattered islands. So he writes a proposal to connect them. His big idea comes down to exactly one thing: plant a path inside a document that jumps straight to another document. You press a word, and you're there. No flipping pages. That jump? That's the hyperlink. That's the H in HTML. Hypertext, text you can leap through. One rule. Documents can point to each other. That single line of link multiplied into billions, until the world's documents were woven together like a giant spiderweb. Which is, yes, why we call it the web. And oh, he almost named it something else. On his list of rejected names was the information mine. He killed it because the acronym spelled TIM. His own name. Honestly? We dodged a bullet. Okay. You want to build a system that links documents. What's the absolute minimum you need? 3 things. And unbelievably, Berners-Lee built all 3 in about 1 year. They're still running today, 30 years later, basically unchanged. 1. A way to write the document, so a title reads as a title and a link as a link. That's HTML, the structural blueprint. What is this thing made of? 2. An address, so you can find the document among tens of billions of others. That's the URL, a coordinate on the map. Where is it? 3. An agreement for how 2 computers actually swap the document. I ask, you answer. That's HTTP request, response, done. How is it exchanged? Structure, address, agreement. HTML, URL, HTTP. Get those 3 questions straight: what, where, how, and you will never tangle them up again. Now let me hand you one weird little fact about HTTP, because it explains half the headaches you'll ever hit. HTTP has a terrible memory. On purpose. It handles your request, sends back an answer, and then instantly forgets you ever existed. Next time you knock, it greets you like a total stranger. The fancy word for that is stateless. Why would anyone build it that way? Because a server has to face millions of people at once. If it tried to remember every single visitor, its head would explode. So it chooses to forget. The price of that forgetfulness is stuff like, wait, how do I keep someone logged in? But that's a problem for region 2, the back end. For now, just carry this, HTTP answers once and forgets. So the early web, with those 3 pieces in place, was honestly kind of boring. Text, links, and not much else. And every page worked the same dead simple way. You write an HTML file ahead of time, you park it on a server, and when someone asks for it, the server hands it over untouched, exactly as is. Restaurant version, this isn't cooking to order. It's pulling a pre-made boxed lunch out of the fridge and handing it over. Which means every single person gets the identical box. Morning or midnight, New York or Tokyo, same lunch. That's a static page. It looks the same to everyone. And that was fine, until people got greedy. Show me my cart. Show me my dashboard. Show me results for my search. But a boxed lunch can't do that. You can't hand everyone the same file and somehow make it personal. That hunger is exactly what pushes up the next mountain range, the dynamic web, the kitchen that cooks each order fresh. But that kitchen lives in the back end. Beyond this ridge. Before we move on, meet the man who built this land and then did something almost nobody would do. Tim Berners-Lee. He builds HTML, URL, and HTTP in a single year. His boss approves the whole project with the world's most lukewarm review scribbled on the cover, vague, but exciting. And then, in 1993, comes the real plot twist. CERN releases the web's source code into the public domain. No patent. No royalties. Free for the entire planet, forever. Think about what he walked away from. He could have owned the web. He could have been on every rich list on Earth, right next to Gates and Bezos. He chose not to. And that single choice is the only reason the web became everyone's land, instead of one company's private mall. The most valuable thing he ever made, he gave away. And the road under all of this? That was paved by Vint Cerf, the father of the internet, the guy who, with Bob Kahn, designed TCP/IP, the agreement that lets computers talk without losing your data along the way. Here's the human part that gets me. The man who made every machine on Earth hear each other perfectly spent his own life fighting to hear. Born premature, progressive hearing loss, a hearing aid from age 13. His wife Sigrid was deaf too, and the two of them first met at a hearing aid shop. The man who built the world's road spent the rest of his life insisting that road leave nobody behind. Not a bad person to have at the foundations. Okay. We've got bare ground. Now let's paint it and make it move. Start with paint. In the early days, developers jammed every color and font straight inside the HTML. This heading is red, make it bold, written right there, next to the text. Fine for one page. Now picture 100 pages, and your boss says, change every red to blue. The color settings are scattered across 100 files. You open all 100. You fix them one by one. Miss one, and it stays stubbornly red. That's not coding. That's whack-a-mole. So in walks CSS. The idea is dead simple and kind of genius, split structure from style. HTML keeps only the meaning, this is a heading, this is a paragraph. A separate file, the CSS, owns the looks. Now change red to blue once, in one place, and every page flips at once. 100 moles, flattened in a single swing. And here's the thing everybody misses, CSS wasn't invented to look pretty. It was invented to be easy to fix. There's a word hiding inside the name. CSS, cascading style sheets. A cascade is a waterfall. Style flows downhill. Two things flow. First, inheritance, set the font on the whole page, and every paragraph inside drinks up the same font, like water running into a valley. Second, specificity, when two rules fight over the same element, who wins? Common sense wins, the one that points more precisely. This specific paragraph is red beats all paragraphs are black. The sniper beats the shotgun. So the next time you swear you set a color and it just won't take? That's almost never a bug. 9 times out of 10, some more specific rule quietly overruled you. The cascade isn't chaos. It's order. Flow, and priority. Grip those two words and 80% of CSS just makes sense. The paint's on. But the land is still dead. Press a button, nothing. Type something, the page just stares at you. It's a pretty picture and nothing more. Then, in 1995, a company called Netscape slaps together a language for its browser in 10 days. 10 days. That's JavaScript. And that rushed little language? 30 years later it runs basically the entire web. Now let me kill the most common mix-up in all of programming, right now. Java and JavaScript are not the same thing. The similar name is pure marketing piggyback. Java was hot, so Netscape borrowed the buzz. How related are they, really? It's not guitar and guitarist. It's more like ham and hamster. The first few letters match. That is the entire relationship. Get that wrong when you talk to an AI, and you'll wander off a cliff wondering why your browser code is written in the wrong language. So how does JavaScript actually shove a page around? It needs something to grab. That something is the DOM. The second the browser reads your HTML, it rebuilds the whole page in its head, not as text, but as a living model. Take a flat paper map and stand it up into a little 3D miniature city. JavaScript doesn't rewrite the paper. It reaches into that miniature, grabs a building, repaints it, raises a new one, tears another down, and it shows up on your screen instantly. And what decides when all this fires? The event. A click, a keystroke, a scroll. JavaScript ties a string ahead of time. When the doorbell rings, open the door. Signal comes in, model changes, screen reacts. That one little loop is the beating heart of every interactive page you've ever used. So here's the clean way to hold all three in your head. Think of a theater stage. HTML is the stage setup, what's physically out there. CSS is the lighting and the costumes, how it all looks. And JavaScript is the director, running around mid-show, swapping props in real time. Same stage, three different jobs. They're not rivals, it's a division of labor. And the moment you blur that line, say, by jamming color straight back into your HTML, you drag yourself right back to that 100-file whack-a-mole from a minute ago. Keep the jobs separate. Structure, style, behavior. But the second the web started moving, a fresh nightmare crawled out. There wasn't just one browser. Late 90s, Netscape and Microsoft's Internet Explorer go to war over market share. We literally call it the browser wars. And with no agreed rules, each side crammed in features however it felt like. The result? The exact same code drew a different picture on every browser. For neat boxes in a row over here, the same four collapsed in a heap over there. Developers didn't build a page once, they built it, then tested it by hand in Netscape, in IE, in this, in that. That grind even had a name, the cross-browser problem. It was pain wired straight to your paycheck. The patches were duct tape. Vendor prefixes say the same thing again in each browser's dialect. Polyfills, a temporary bridge faking a new feature for an old browser. And every time a new browser shipped, the bridges fell down and you rebuilt them all over again. So people finally got smart. Stop building a bridge for every gap. Pave one road to one shared spec for everyone. That agreement is the web standard, herded along by a group called the W3C. Follow the standard, and a page you build once stands up the same in every browser, and all those hours you burned on duct tape go back into building the thing you actually wanted. And winning that standard wasn't all polite meetings, by the way. In 2005, the guy who invented CSS threw down the Acid 2 test, a page that's supposed to render a clean little smiley face. Follow the rules, you get a smile. Break them, and the face comes out warped and shattered. It was a public scoreboard that showed, at a glance, exactly which browser wasn't playing fair. Sometimes standards win by shaming. Alright, let's sneak behind the stage. How does all this HTML, CSS, and JavaScript actually become a screen? 4 stages. Lock these in and a real map clicks into place. Stage 1, parse. The browser reads your HTML top to bottom and draws 2 blueprints, the DOM, the skeleton, and the CSSOM, the style rules. Stage 2, the render tree. Overlay the two, and keep only what'll actually show up. Hidden stuff drops out. Stage 3, layout. It calculates where every element sits and how big it is, arranging the furniture in an empty room. Stage 4, paint. Finally, color, images, borders go down, and a visible screen appears. Read. Combine. Place. Color. That's the pipeline that turns your code into pixels. And here's the part that actually matters for speed. When JavaScript changes the size or position of something, the furniture layout is wrecked, so the browser has to recompute that whole placement stage from scratch. That's called reflow. If you only change to color, positions hold, and it just repaints, that one's cheap. Reflow is the expensive one, because moving one thing can shove everything around it. Analogy: repainting a picture frame is cheap. Dragging the sofa across the room and replanning the entire floor is expensive. A room with 10 pieces? Instant. A room with 10,000? It seizes up every single time you nudge one. So when a screen stutters, 9 times out of 10 the villain isn't how much code you wrote, it's reflow firing over and over. Change things once, in a batch. Not 1,000 times in a dribble. That one habit is half of what people call front-end performance. Now, if drawing a screen were the whole story, this lecture would be over. It's not. Because there's one force we haven't dealt with yet. Scale. A corner shop with 2 pages? Build it by hand, no problem. But blow that up into a shopping mall, a social network, a mail service, hundreds of screens, all changing constantly with the data behind them, and the hand-built way just collapses. The road got wider, but nobody put up signposts, and people start getting lost. So here's the pattern for the rest of this chapter, and honestly for all of software. Every tool we're about to meet was born at the exact moment the hand-built way broke under pressure. Complexity builds, hits a critical point, and boom, a new signpost rises. Watch for that rhythm. First signpost, jQuery, 2006. Remember the cross-browser hell? To change the screen, you had to find an element and repaint it, but the commands were different in every browser. So your code forked 2-3 ways, in IE do this, in Firefox do that. A separate signpost at every fork. jQuery tied all those forks into one. Its pitch: every browser speaks a different command? Fine. You speak one way, and we'll secretly translate it for each browser underneath. 10 lines of code shrank to 1. Its actual slogan was write less, do more. For years, jQuery was the common tongue of the web. You'd open any big company's site and find it sitting right there inside. So why'd jQuery fade? 2 reasons. Browsers finally agreed on a standard, so the translation got less necessary. And a deeper limit showed up: jQuery directs everything by hand, one element at a time. Fine on a simple page. But on a screen where your cart, your coupons, and your login state are all tangled together, a human had to track, by hand, okay, what parts of the screen do I fix now, and how? That approach hit a wall. And here's the funniest footnote in web history: John Resig, the guy who built jQuery? He said that these days he just uses React and TypeScript. The man who built the translator was the first to admit out loud the era of the translator was over. That wall summoned React, 2013, out of Facebook. And it flipped the whole idea on its head. The old jQuery way is called imperative: you bark out every step. Find this, do that, then find this, then do that. It's like calling a cook one beat at a time: pot on stove, light flame, pour water, wait. Fine for one dish. Pile up 100 orders and your head explodes. React said, stop dictating the steps. Just declare the result you want. Table 5, pasta, done. How we get there is our problem. That's called declarative. Imperative is barking turn-by-turn directions. Declarative is dropping a pin on the map and handing it to the GPS. At the heart of React is one word: state. State is everything the screen has to remember: what's in the cart, is a coupon on, are you logged in? And React's promise is beautiful: when the state changes, the screen changes with it, on its own. You just say, change the data. Figuring out which pixels to update? That's React's job now. All that tracking that tortured humans in the jQuery years got handed to the tool. 2 more quick ideas. Components, reusable parts. A mall with 1,000 product cards doesn't build the card 1,000 times. You build one card, then stamp copies, swapping only the contents. Lego bricks. An abstraction, capping the messy insides with a lid and leaving one simple button outside. Like a coffee machine, press the button, coffee comes out, and you never think about the beans grinding inside. And you'd think a tool this clever got a hero's welcome. Nope. The exact opposite. When React was first shown off, the room went cold. People especially hated JSX, mixing HTML-looking markup right into your JavaScript. A massive step backward, the reviews said. The team honestly wondered if open sourcing it was a mistake. What turned it around was one talk, with one line: don't look at the code. Look at the problem it's trying to solve. Lesson worth keeping: even great tech gets buried if you can't explain why it exists. Facebook didn't even order React from the top. By the way, they made two teams compete for 30 days, React versus the popular tool of the day. After 30 days, the choice made itself. Okay, so we're assembling screens out of parts now. Which raises a lazy, reasonable question: are you going to carve every part by hand? A calendar, date math, a chart, somebody out there already built these, well. So you grab theirs. Almost overnight, the frontend quietly became an assembly industry. The giant warehouse where all those parts live is npm. One command, and a part drops into your project. And here's the clever bit: if your part leans on another part, which leans on another, npm fetches the whole chain automatically. Order one piece of furniture, and the screws and brackets show up in the same box. That chain of parts riding along is called a dependency. Remember that word. It's about to cause a disaster. But grabbing parts isn't the finish line. Before it ships, your code runs through a factory called the build. And you only need 3 stations on that line. Transpile, you write in modern JavaScript, but old browsers don't speak the new slang, so it gets auto-translated into old, universal syntax. Bundling, hundreds of tiny files would make the browser do hundreds of trips, so you cram them into 1 or 2 containers and ship it all in one haul. Tree shaking, the warehouse dragged along features you never use, so this shakes out the deadweight right before shipping, and the screen loads lighter and faster. One line to tattoo on your brain: the code you write and the code that ships to users are not the same thing. It almost always passes through this factory first. Now, that disaster I promised you. 2016, a developer got into a fight with a company over a package name. Furious, he deleted all 273 of his packages off npm in one shot. One of them was 11 lines long. 11. All it did was pad some spaces onto the left side of text. It was called leftpad. And the entire internet's build system fell over. Because Babel, Webpack, React Native, the giants all quietly depended on it, deep down the chain. Meta, PayPal, Netflix, Spotify hit. One invisible 11-line screw fell out of the furniture, and the whole house shook. That's the dark side of the assembly industry. So when you build with an AI, keep the chain short. If you can write something small yourself, don't drag in a giant package for it. Leftpad taught us that in blood. Almost home. One last fork: how do you swap a screen out? 3 paths. Old way, MPA, every page is a full document on the server, so every click fetches the whole thing fresh. Cue that white flash before it redraws. Like walking out the front door and back in every time you change rooms. Then came SPA, load one heavy chunk of JavaScript up front, and after that, never fetch a new page. JavaScript just swaps the contents inside the same page. Smooth, no flicker, like an app. But there's no free lunch. SPA pays twice. The first load is slow, you're staring at a blank screen while that big bundle downloads. And it's bad at search. Google's robot shows up, sees an empty page before the JavaScript runs, shrugs, nothing here, and leaves. Like opening a shop with a blank sign, the search map never finds you. So is there a way to get both? That compromises SSR, the server predraws a finished screen, content and all, and sends that first. The user sees stuff instantly, the search robot reads a sign that's actually printed, and JavaScript layers on afterward to wake it up. The tool that juggles this best is Next.js, some pages drawn on the server, some in the browser, mixed inside one project. And that's the real lesson of this whole region: technology is always a trade-off. There's no right answer, only the right choice for this job. Same story out at mobile, a whole spectrum from purest native, fastest, and deepest into the device, all the way to WebView, where you just wrap the web you already built. React Native, Flutter, Capacitor, each one parks somewhere along that line. You don't memorize them. You place them. Okay. Breathe. Look how far we climbed in one lecture. We split the internet, the road, from the web, one mail system driving on it. We watched Tim Berners-Lee spin the whole thing out of a single hyperlink and give it away for free. We met the 3 gears: HTML, URL, HTTP, what, where, how. Static pages handed everyone the same boxed lunch. Then CSS painted the land, JavaScript made it move, and the browser wars forced everyone onto one standard road. And when the village grew into a metropolis, the signposts rose right on cue. jQuery tied the forks together. React said, manage the state, and the screen follows. NPM and the build turned us into an assembly industry, leftpad and all. And SPA, SSR, and Next.js sorted out how to swap a screen. Notice what we did not do. We didn't memorize a single thing. We followed the pressure, what problem pushed up each peak, and the names came along for free. That's the whole method. And it's exactly how you stop being a passenger and take the wheel back from the AI. Everything you just learned is chapter 1 of a book called the AI Development Atlas. 10 regions. 1 map. The frontend was just the first ridge, beyond it lie the backend, databases, deployment, machine learning, transformers, RAG, agents, the whole continent. It's written for exactly one purpose, so that you can command the machine, instead of riding shotgun while it drives. If this lecture made the fog lift even a little, the book is the full map. Its tagline says it best, only those who know the terrain can command the AI. This has been a DK Corp production. We build the maps, so you can command the machines.